here's our second video from the packet about Intro to Parametric and Vector Calculus. And so we finished kind of doing the introduction parts parametric, and so now we're going to talk about some of the calculus parts. And so we're talking about having a curve here that's defined by equations x equals f of t and y equals g of t. So you have two functions, or you have two equations there to determine your function, and they're both in terms of t. Then it says then the slope is given by dy dx. So this is not changed. It is dy dx. That is the slope just as the way it's always been. The difference is just that your equations both have t in them. Well, guess what? It's super easy. All you do is take the derivative of y with respect to t over the derivative of x with respect to t. So it's actually super simple. So there's your dy dx. To do the second derivative, you do the derivative of the derivative, of course, and what that ends up doing is giving you the derivative of the answer that you just got. So whatever you got for dy dx, you take the derivative divided by dx dt. And that was this here at the bottom. So you're going to divide by that. If you do the third derivative, you're going to take whatever answer you get. When you simplify all of that, you'll take its derivative and you'll divide it by, again, dx dt. So there's always just that dx dt that you divide by in the end. You always just take the previous derivative, take the derivative of the previous equation, and then divide it by dx dt. So no matter how many times I'm going to keep going, that's what I would do. So let's do an example. So example 4 without a calculator here. So we're going to find the first and second derivatives and evaluate at t equals 1. So the first derivative means I need to find dy dx. So dy dx equals dy dt divided by dx dt. Now sometimes you'll see it written, and you should get in this habit of writing this, y prime at t divided by x prime at t. And I will often write it that way. It's much easier to write that instead of having the compound fractions like that. So that's basically what we're going to do. So it just simply means take the derivative of the y with respect to t. So that will be 6t minus 2 all over the derivative of x with respect to t. So let me write this here. It's 2t to the 1/2. So when I do the derivative, I'll get a half times 2, which is 1, t to the negative 1/2. Now, if I was done, if that's all they asked me for was what's dy dx, I would stop there. There's no reason to simplify that further. I don't know what I need to use it for. Plus, if I'm going to evaluate that when t equals 1, why would I do anything else? All I have to do is plug 1 in. However, in this problem, it's asking me to go ahead and go further and do the second derivative. So I do need to go ahead and simplify this a little bit. Otherwise, like I said, I'd have just boxed this in and I would be finished if that's all I needed. But since I've got to find the next derivative, I probably want to simplify that a little bit. So you can either think of it like t to the negative 1/2 means t to the 1/2 in the top, or you can just do your exponent rules. Several different ways to do that, but basically you're going to have 6t to the 3/2 minus 2t to the 1/2. So that negative exponent means you'd basically move it up, and it goes with each of the things on the top. So that's a little bit easier to get an answer for dy dx if I'm in fact, again, going on. So either one that's boxed in is fine. But since I'm going to do the second derivative, I'm going to go ahead and write it that way. So now to do the second derivative, okay, what that's going to be is we're going to take the derivative of dy dx. So that's this function I just circled in. So we're going to take this derivative right here, and then we're going to divide it by dx dt, which is t to the negative 1/2. And that's how we do the next derivative. So when we take this derivative, we'll have 3/2 times 6. So that's going to be 9. So we'll have 9t to the 1/2, because I'm doing the derivative, minus, and I take the power in front, 1/2 times 2 is again 1 times t to the negative 1/2. So that's the derivative of y. Now I divide it by this right here, this dx dt that I just found. So that's t to the negative 1/2. And that's all there is to the second derivative. Now, if the first derivative had really been a quotient or other things, then obviously the numerator there would have been more complicated. But it's pretty simple. It's pretty straightforward. Just take the previous one, do its derivative, and then divide it by dx dt. So again, if I were finding the third derivative, I would simplify all of that, find the derivative. Now let's go ahead and simplify that then, just to see what would happen if I were to do it again, because this actually simplifies kind of nice, because t to the 1/2 over t to the negative 1/2 is just t. So I get 9t minus, well, t to the negative 1/2 over t to the negative 1/2 is 1. So if I were to do this derivative again, I would simply get 9, and then I would divide it by t to the negative 1/2, because that was dx dt. If I did the derivative again, I would just keep doing that and so on. Okay, so you just keep dividing by dx dt after you do the derivative. Now the question said evaluate these at t equals 1. So let's go ahead and evaluate both of them. It's kind of unclear if it means both, but we'll go ahead and do it. So remember notation. dy dx evaluated at x equals 1. That's an easy way to write that, or t equals 1, sorry, to show exactly what you're doing. So dy dx at evaluated at, that's what that vertical bar means, remember, so at t equals 1. So that means just plug in 1, so that's 6 minus 2, which is 4. So I've just shown a whole bunch of stuff without writing a lot of stuff. Here, second derivative, and I want to evaluate it at t equals 1 also. So I simply write that evaluated at t equals 1, and so I'll get 9 minus 1, or 8. And that's it. So it's not difficult at all to do these derivatives. It's just different. Okay, so you just got to get used to that. So let's go ahead and go to example 5, and this will help review some other things we need to do, which this has to do with writing an equation of a tangent line. So we've got to remember, what do we have to know to write an equation of a line? We have to know a point, and we have to know the slope. Well, the slope we get by finding dy dx. That's the slope of the tangent line at any certain point. So we want to find dy dx, and we want to evaluate it when t equals 3 pi over 4. So if we want the point, the xy coordinates, then we'll have to plug this in here for both of these, and then that just gives us the xy point that we're talking about. So let's just go ahead and do that, because we can kind of do it there above. So cosine of 3 pi over 4 would be negative square root of 2 over 2 times 4. So x would actually equal then negative 2 square root of 2. And if we plug in 3 square root of 4 into y, we'll get sine of 3 pi over 4, which is square root of 2 over 2 times 3. So that's 3 square root of 2 over 2. So there's your point. So now all I have left to do is figure out what's the derivative. And that gives me the slope. So I want to find y prime of t divided by x prime of t. So y prime, taking that derivative of sine is cosine. So we get 3 cosine t over derivative of cosine is minus sine. So we get minus 4 sine t. And we can just leave it because, again, unless we know what we're doing with it, let's just leave it alone. If we knew we needed to do something else with it or find another derivative, I might want to change it, but I'm just going to leave it. So here's my derivative. Now I need to find my slope at that point. So I need to find what is dy dx when t equals 3 pi over 4, because that's the slope that I need for this line. So we get 3 times cosine of 3 pi over 4, which was negative square root of 2 over 2, over negative 4 times sine of 3 pi over 4, which was positive square root of 2 over 2. So your negatives go away, your square roots of 2 over 2 go away. So our answer will be 3/4 there. So to write the equation of a line, remember, don't overdo it. They didn't say what form to put it in, so just do y minus the y value which is 3 square root of 2 over 2, equals the slope, which we just found was 3/4 times x minus the x value, which is negative, so minus negative is plus. 2 square root of 2, finished. And that's it. Don't simplify it, don't do more than that, because what if you mess up when you multiply stuff out and you make a mistake, and then you're going to be wrong. Here you're right, because we just wrote it down and didn't do a lot with it, okay? So we leave it there. Now, if they said something like estimate, you know, the value of whatever when x is some number, then you would need to plug it in and simplify. But right now we're good. That's the equation of the tangent line at the point where t equals 3 pi over 4. Now the slope also, again, is telling us this 3/4 is saying at 3 pi over 4, when we're at that place, that's how dy dx is changing. That's the rate of change, okay, the instantaneous rate of change. All right, so let's do example 6. So this one says, again, without a calculator, find the points of horizontal and vertical tangency, okay? So, well, again, I'm going to have to figure out, in order to get a horizontal tangent, it would mean that the slope, well, what's the slope of a horizontal line? That would mean the slope is 0. If there's a vertical tangent there, it would mean that the slope is undefined, which would mean the bottom is 0. So basically, I need to find dy dx first, and then I need to do things with it. So dy dx, the derivative of y is going to be 2t minus 3, and the derivative of x is 2t plus 1. So very simple. Now, if I want to find horizontal tangents, then I need to write something down for kind of explaining what I'm doing without using a lot of words. Well, all I have to do is say derivative dy dx equals 0 over not 0. That's sufficient. I've explained what I'm doing. I'm looking for where's the top 0 and the bottom is not 0. So all I have to do is solve when is 2t minus 3 equal to 0, which would be, of course, when t is 3/2. So when t is 3/2, I'm going to have a horizontal tangent line. Well, that doesn't make sense, because to just say that, though, it says points. All points of horizontal and vertical tangency. So it's saying on the graph, at what point do you have a horizontal tangent line? So I need to plug in that t equals 3/2 into the equations to get my x and y coordinates. So I've got that x equals t squared plus t, and y equals t squared minus 3t plus 5. Well, now I need to plug in my value that I found. So that's 3/2 squared plus 3/2. And then this would be 3/2 squared minus 3 times 3/2 plus 5. Now, if this is a free response question, I don't need to simplify it. So all I would do is simply make this an ordered pair. And I'm done. I don't need to do any more than that, because I could end up making a mistake. This is a numerical answer. That's a number. It's not completely simplified, but there it is. Okay, and that works. All right, so now let's do vertical tangents. So for vertical tangents, then again, we just need to say the same thing. If I've got a vertical tangent line, then that means I want to know when is dy dx equal not 0 over 0. That's what I'm looking for. So now I just set the bottom equal to 0. Well, the bottom of my derivative was 2t plus 1. So I want to know when is 2t plus 1 equal to 0. So that's when 2t is negative 1, t is negative 1/2. So again, I'm going to do the same thing for my point here. When I give my answer, I'm not going to overdo it simplifying it, because I don't need to. Now, if it was a multiple choice question, then of course I would need to get it to look like whatever I'm looking at. But my x coordinate is simply going to be negative 1/2. Now be sure that you put, if you're going to square something or cube something, you put it in parentheses. So it's negative 1/2 squared minus 1/2, because it's plus negative 1/2, comma, that's the x value, negative 1/2 squared minus 3 times -1/2 plus 5. And that's it. That's my point, and I can stop there, and I don't need to do any more than that because that's a numerical answer. It's fine. Again, unless it happens to be on a multiple choice question, then you need to make it look like something else. Okay, so let's go to the next example about arc length, and that's all we'll do for this video, and then we'll continue on with the rest of this stuff on a third video for the rest of this packet of notes. So we have arc length for parametric. It's a very simple formula. To find the length of the arc from t equals A to t equals B, so that's important. Those are t values, which you can tell because this says dt. So whatever variable that is, that's what your limits of integration are. So the arc length L is simply the square integrating from A to B of the square root of dx dt squared plus dy dt squared. So it's basically just the Pythagorean theorem. If you think about your vectors and how you would have a change there, you would have a dx dt, so you would have some sort of vector in the x direction, and you'd have some sort of vector in the y direction. And then I want to figure out basically what is the resultant vector. And if you remember, you kind of take one vector, like you take that vertical vector and you move it over so that it's got its tail on the head of the other one. And then what I'm interested in is what is this length. That's what I'm looking for basically. And so to look for that is just the Pythagorean theorem. I need the dx dt change squared plus the dy dt change squared, and that's what I'm looking for, okay? So I'm just trying to find the length here. Now, regular arc length, you also need to know this formula. So if I'm in regular equations, I'll just call them regular, so not in parametric, I'm going to go from A to B, which are going to be x values, and I'm going to do the square root of 1 plus f prime of x squared dx. And that's how we would do a regular equation. So you would find the derivative of x, and you would square it, and you'd put 1 plus that, square root it, integrate from A to B. So that's the difference in the equations. All right. So let's say without a calculator, so let's use this formula, find the arc length of the given curve if we have this going on. So that means that the length is going to equal, we are going to integrate from 0 to 1, because those are my values that I was given there, square root of, it's going to be dx dt, so the derivative of x with respect to t, which would be 2t squared, plus, now I got to do the derivative of y over here. So the derivative of y with respect to t is 12t squared, and then I got to square that, and then this is dt. Well, since it's not a calculator problem, that means I've got to be able to find some way to do this integral. So this is good practice. Let's go through this. So first thing I would do is I would square my stuff underneath to see what we have here. So we have 4t squared plus 144t to the fourth dt. Well, since you're under a radical, it would seem like a good idea to factor out a 4t squared from each of those terms. So underneath the radical, just take out 4t squared, and then you would be left with 1 plus 36t squared dt. Now, the reason that was helpful is this is multiplication now because I have 4t squared times this quantity. So I can square root separately the 4t squared, which will give me a 2t, and then I have square root of 1 plus 36t squared, and then dt. Now the reason that helped is because now I can do a u substitution. Because my inside here, my 1 plus 36t squared can be my u, which means du would be 72t dt. So I'm going to fix that, which I have a 2 here currently, so I need to multiply by 36. That'll give me a 72 there. So I'll have 72 dt, because that way I've got right here 72 t dt. So that's what I need it to say. But remember, I can't just multiply by 36, so outside I got to divide by 36 and make a 1 over 36. So now to integrate this, that's going to be 1 over 36. And so what you're actually doing here is just u to the 1/2. So that whole entire thing. Now I'm going to rewrite it, and I'm going to write t equals 0 to t equals 1. Make sure you can all see this. I'm really just doing square root of u du, because I've just changed everything. So that's very simple to integrate. And so most of the time we wouldn't need to rewrite that with the u in it. So let's just go ahead and go, let's do 136 times. If you integrate something to the 1/2, you're going to get something to the 3/2. So instead of u, just write 1 plus 36 t squared to the 3/2 times, instead of, you're going to divide by 3/2, because we divide by the power, we're going to do times 2/3. And then we're doing this from 0 to 1. So 136 times 2/3 is going to be 1 over 54. So to get rid of that, because you can basically keep your constants out in front, and then I plug in a 1, I'm going to get 36 times 1 is 36 plus 1, that's 37 to the 3/2, minus plugging in 0, which will give me 1 to the 3/2. And then not really anything else I can do here, because I certainly don't know the square root of 37 or anything, so I'm finished. And that's my final answer. So if you had trouble following that, be sure you hit pause and go back and look through that again, because that is a technique that might help you do an integral later. So basically, we filled in the formula. That part was easy. Then we just had to look and say, well, I got to somehow be able to do this integral. So I noticed that there was a t squared in common and a 4, which are both perfect squares, which makes life easier because then I got a 2t out front. Then the rest of that's just regular u substitution and go until I get my answer, which again, got to just leave because it's not a calculator problem and I have no idea what that equals. So that's the second video completed, and we'll have a third video on this, and then we'll have a video on another section, and that will be it for parametric.